I'll instead say string, my result. Okay. And here I will write the contents. What will happen here, it will block on delay, like normal code. It will block the thread. I'm looking for 5 seconds. It will block normally. Then it will hit the first await. This means it will create a task and handle it, but it will return immediately to the caller. So after this line, after it hits await, it will go back here to the caller. It will not do this line. Okay? Automatically, after the task is finished, it will come back to this line at the main thread. So you understood this? So simply, this will be the same code if I do it here. This is the normal code. I'd rather have this one, the same string. Just to make it clear. So actually, it's the same code. All I have to do is add here the async keyword and await here. So converting your existing code to asynchronous code in CTP is quite easy. Okay? And the compiler will figure out how to rewrite the code. Actually, it will rewrite your code. Make it with the old callbacks and the continuation in order to continue at the same point. And you can have multiple awaits. Okay, like here, I will write it in the database. I will make await call. Whatever operation. Okay? And another blocking operation. So what will happen is, whenever I'm calling this, I will go sequential normally until I hit the await and come back immediately. Whenever the task is finished, I will continue my code. This is simple? Not simple, it's easy.
Continue to the line before
next,
the await.
After the wait.
If I call the await, it will back to the function.
Directly, yeah.
And after
the task is completed,
it goes to the await line.
Yeah, it will continue after the wait line directly. Continue the normal code.
It will not execute the delay and sync.
No. Delay is the beginning. It will go through it until it hits await. Whenever it hits await, it will manage creating a different thread and everything. Return immediately. Whenever the task is finished, it will go back to it. Continue the code. I think this is much simpler than.
It should be void?
No. I will talk about it. There's two types. It can be void and it can be something else. Okay, but I'm just showing you. So, if you compare this code with this one, the only difference is async and await. But you have to be aware of the flow of your code, how the tasks will flow. Okay? And you can cascade this. Okay? Actually, this one, it's an async call, which have awaits inside it. Okay? So you can cascade it. Like if you are downloading multiple pages, you can write a sync operation to download multiple pages and continue cascading them. So await await takes a synchronous call. You don't have to worry about anything. You just design your flow according to this.
When we use the keywords await and asynchronous, do we have to take care of deadlocks?
No, you don't have this. Actually, this deadlocks for what? Inside the task? No. The concept of a task is it's doing something and returning a result. Okay? It will not be it will not be allowed to do something in the main thread or anything. So simply isolate this function and that's it. Okay? But don't care about it, don't care about anything. But you might have risk conditions if you have a parallel. If you have multiple threads accessing the same, or multiple operations accessing the same variable at the same time. This is where we have to, and writing to them. Even if you have a parallel process or multi-threading application, and they are accessing the same value, but not writing to it, you don't care about deadlocks. Deadlocks is writing values. When you change the value of a variable, and multiple threads are trying to access it. This will have the risk condition. But here, you don't have to care about it. Because actually you are doing all the stuff on the main thread. You are not going into a different thread eventually. You are utilizing your thread. Okay? And actually what will happen for the task, it will try to, but you have to make it small. This task has to be small because it will be executed on the main thread. It will not create a different thread. It will be executed on the main thread, on the calling thread. Everything is done on the main thread, but you are returning control to your thread, okay? And at a later point in the future, a later point of time, it will come back to you. The concept is clear?
I know the concept.
Whenever it finishes, it will come back to you. The control will go automatically. I had a question here. No?
Is this feature available in C#?
Yeah, this is Visual Studio 2010. It was Service Pack 1, but you have to install the CTP. Okay? It's in MSDM. 19 meg you can install, but it takes time to install, apparently. Any questions? So, the await keyword at the compile time, the compiler will generate all the code necessary to make the continuation of the code and the callback function. It will return immediately to the caller, okay, whenever it hits the await. Then it will await in the background for the task to finish and continue the body of the function. It will continue the normal code flow. The nice thing about await is it's also propagating exception. One thing about asynchronous development that you'll have a problem propagating the exception, catching the exceptions, where it will go. It will go in the callback function or in the main calling function. Okay. Here, await will propagate it to the calling function normally. Okay, so if this code, here have a try and catch.
So if web client throws an exception, we catch it here.
Yep. And not only the exceptions, there's a special type of exception. So it will come here. If this function internally have an exception, it will come here. It will be caught here. Okay? This is a very nice feature. And there is a special type of exceptions for cancellation. If you work with tasks in .NET 4, there's something called cancellation token. Cancellation source, and you can get something called cancellation token. Okay? The cancellation token, whenever anybody is calling this token and saying cancel, anything it's implemented, so here just the way you only have to add is the cancellation token. Like this. Whenever